The 2005 National Electrical Code restricted the use of non-shielded cables to 2400 volts in new installations. However, if you have an existing installation with non-shielded cables operating at higher voltages, there are ways to adapt the system to meet current safety standards and best practices. Let's explore some options. One option is replacing the existing non-shielded conductors with shielded conductors that are rated for the operating voltage, in this case 4160 volts. This is generally considered the most compliant approach with the NEC, and it offers the best protection against electrical hazards. Shielded cables contain a conductive layer, typically made of copper or aluminum, that surrounds the insulated conductors. The shield helps to contain electrical fields and prevent them from radiating outward. It also provides a path to ground for fault currents, improving safety. Replacing the cables involves significant labor and material costs. The cost of shielded cable is higher than non-shielded cable, and the labor to pull the new cable and terminate it can be substantial. Consider the length of the cable run, the accessibility of the cable route, and the number of terminations required when estimating the cost. Another option is retrofitting with insulation shielding. This involves installing a conductive layer around the existing non-shielded conductors. This layer acts as a shield to mitigate corona discharge and reduce the risk of arcing and insulation failure. Corona discharge is a phenomenon that occurs when the electrical field around a conductor becomes strong enough to ionize the air, creating a faint glow and a buzzing sound. Over time, corona discharge can degrade the insulation of the cable, leading to failure. Retrofitting with insulation shielding involves applying a conductive material, such as metallic tape or conductive paint, to the surface of the cable insulation. The conductive layer must be properly grounded to provide a path for fault currents. Not all insulation shielding systems are created equal. Approved insulation shielding systems must be tested and listed for use with a specific voltage and cable type. The manufacturer of the shielding system should provide detailed instructions on how to install the system properly. Improper installation can negate the benefits of the shielding and potentially create new hazards. Another option is using shielding kits. These kits typically consist of prefabricated metal enclosures that clamp around the existing non-shielded conductors. The enclosures provide a physical barrier that shields the conductors from external influences and contains any arc flash that may occur. Shielding kits should be specifically designed and approved for the voltage and cable configuration. Make sure the kit is compatible with the size and type of the existing cable. Also, ensure that the kit is properly grounded to provide a path for fault currents. When selecting an adaptation method, consider several factors, with safety being paramount. Always consult with a qualified electrician and follow all applicable local building codes and regulations. Working with high voltage electricity is inherently dangerous, and only qualified personnel should perform the work. The cost of adaptation will depend on the chosen option and the extent of the work required. Replacing the cables with shielded cables will generally be the most expensive option, while retrofitting with insulation shielding or using shielding kits may be less expensive. Get quotes from multiple contractors to compare costs. Shielding kits and conductive materials may not be readily available for all cable configurations. Check with your local electrical suppliers to determine availability and lead times. Adapted installations should be inspected by a qualified electrician to ensure compliance with applicable codes and standards. The inspection should verify that the shielding is properly installed, grounded, and rated for the voltage. In general, replacing the non-shielded conductors with shielded conductors provides the highest level of safety and compliance with the NEC. If replacement is not feasible, retrofitting options can be considered as a temporary solution until the non-shielded conductors can be replaced. Always prioritize safety, consult with qualified professionals, and follow all applicable codes and regulations. Consider the following points when dealing with adapting non-shielded to shielded cable. Firstly, you will need to identify the existing cable type and voltage rating. This information is crucial for selecting the appropriate shielding method and materials. Check the cable jacket for markings that indicate the cable type, size, and voltage rating. If the markings are not visible, consult with a qualified electrician to identify the cable. Secondly, perform a thorough inspection of the existing cable. Look for signs of damage, such as cracks, cuts, or abrasions. Damaged cable should be replaced rather than retrofitted with shielding. Pay close attention to the condition of the cable insulation. If the insulation is brittle, cracked, or discolored, it may be a sign of degradation. Thirdly, ensure proper grounding. The shielding must be properly grounded to provide a path for fault currents and prevent the buildup of static electricity. The grounding conductor should be sized according to the applicable electrical codes. The grounding connection should be made to a suitable ground electrode, such as a grounding rod or a building steel. Fourthly, consider the environmental conditions. If the cable is exposed to moisture, chemicals, or extreme temperatures, select a shielding method that is resistant to these conditions. For example, if the cable is installed in a wet location, use a waterproof shielding system. If the cable is exposed to chemicals, use a shielding system that is resistant to those chemicals. Fifthly, provide adequate ventilation. Some shielding methods can trap heat, which can lead to premature cable failure. Ensure that the cable is adequately ventilated to prevent overheating. This may involve providing air gaps around the cable or using a shielding system that allows for air circulation. Sixthly, use appropriate tools and equipment. When installing shielding, use the proper tools and equipment to avoid damaging the cable. For example, when applying metallic tape, use a taping tool to ensure that the tape is applied evenly and tightly. When installing shielding kits, use the manufacturer's recommended tools. Seventhly, follow the manufacturer's instructions. Always follow the manufacturer's instructions when installing shielding. The instructions will provide detailed information on how to install the shielding properly and safely. Deviating from the manufacturer's instructions can void the warranty and potentially create hazards. Eighthly, test the installation. After installing the shielding, test the installation to ensure that it is functioning properly. This may involve performing a continuity test to verify that the shielding is properly grounded. It may also involve performing a high potential test to verify that the shielding is providing adequate insulation. Ninthly, document the installation. Keep a record of the shielding installation, including the date of installation, the type of shielding used, and the results of any testing. This documentation will be helpful for future maintenance and repairs. Tenthly, provide training. If you are not a qualified electrician, do not attempt to install shielding yourself. Hire a qualified electrician to perform the work. The electrician should be trained in the proper methods for installing shielding and should be familiar with the applicable electrical codes. Remember that modifying existing electrical installations can be complex and dangerous. It is important to consult with qualified professionals and follow all applicable codes and regulations to ensure safety. Additional considerations include the potential for future expansion. If you anticipate needing to add more cables in the future, consider using a shielding method that can accommodate additional cables. Some shielding kits can be expanded to accommodate additional cables, while others cannot. Consider the aesthetics of the installation. If the cable is visible, you may want to choose a shielding method that is aesthetically pleasing. Some shielding kits are available in a variety of colors and finishes. Consider the ease of maintenance. Some shielding methods are easier to maintain than others. For example, shielding kits are generally easier to maintain than metallic tape. Consider the impact on the environment. Some shielding methods are more environmentally friendly than others. For example, some shielding kits are made from recycled materials. Before commencing any work, de-energize the circuit. Always de-energize the circuit before working on any electrical equipment. Use a qualified electrician to verify that the circuit is de-energized. Lockout and tagout procedures should be followed to prevent accidental energization of the circuit. Wear appropriate personal protective equipment. When working with electrical equipment, wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. This will help to protect you from electrical shock and other hazards. Be aware of potential hazards. Be aware of potential hazards, such as exposed wires, sharp edges, and falling objects. Take steps to mitigate these hazards. Keep the work area clean and organized. A clean and organized work area will help to prevent accidents. Remove any debris or obstacles that could trip or injure workers. Dispose of waste materials properly. Dispose of waste materials properly. Do not throw waste materials into the environment. Follow all applicable environmental regulations. By following these considerations and precautions, you can help to ensure a safe and successful shielding installation. Remember to prioritize safety and consult with qualified professionals whenever necessary. Also, consider the long-term implications of your choices. Choose a solution that is not only safe and compliant, but also durable, maintainable, and cost-effective over the lifespan of the installation. Regular inspections are crucial. Even after the adaptation is complete, regular inspections are essential to ensure the continued integrity of the shielding and the safety of the electrical system. Inspection should be performed by a qualified electrician and should include a visual examination of the shielding, as well as electrical testing to verify its effectiveness.